So when this assembly is complete, this bearing is able to take vertical load. It is able to offer rotation, a typical fixed elastomeric bearing, which is placed in between two steel plates. Photograph of the actual bearings installed under a bridge material against this hard steel surface. The sealing element gets worn out and it creates a gap through which the elastomer will come. This material or this area of the sliding material can get contamination also, whereas due to the extreme concentration of load on the other end, unlike the ptfe bearings, in a spherical bearing, we have an interface of concave and convex components, and there is a lining of low friction material in between. This is a fixed spherical bearing. We have a bottom component wherein you could see that after 10 km of sliding, the entire ptfe has crystallized. Of the same very fast movements, they can accommodate high loads and temperature rises. You could see the ptfe starts melting first, or start thickening through these thick bearings. Its application in one of
these images are the actual images of the bearing which is installed at the location at the site. So welcome back all to the All About Bridges. आज हमारे साथ बहुत ही स्पेशल गेस्ट हैं श्री जितेंद्र राठौर, जो कि COO हैं मॉरर सैनफील्ड इंडिया के, जो कि वन ऑफ द लीडिंग बेयरिंग मैन्युफैक्चरर्स हैं ब्रिजेस के लिए। तो आज हम वेलकम करते हैं आपका इस यूट्यूब चैनल पर जिसका नाम है ऑल अबाउट ब्रिजेस। और आज हम इनसे जानेंगे कि ब्रिजेस के लिए डिफरेंट काइंड्स ऑफ बेयरिंग्स हमारे पास क्या क्या ऑप्शंस हैं, किसका क्या यूज़ केस होता है, किसमें क्या लेटेस्ट डेवलपमेंट्स चल रहे हैं, और हम ये भी जानना चाहेंगे कि अभी इन्होंने एक लेटेस्ट नई तरह की बेयरिंग भी इंट्रोड्यूस की है जिसका नाम है पेंडुलम बेयरिंग। उसके बारे में भी हम जानेंगे। इसको पंबन ब्रिज में यूज़ किया गया है। तो वंस अगेन वेलकम टू आवर यूट्यूब चैनल विच इज़ ऑल अबाउट ब्रिजेस राठौर जी, and we would like to hear from you now.
Thank you very much, sir. Thanks for your polite words and your nice introduction. As you have already explained, we have compiled a small presentation to take you through the introduction of various types of bearings, especially keeping in mind the railway bridge applications. We will be discussing in short what are their advantages and limitations. And also we'll be discussing what is the state of the art in terms of bridge bearing applications. And to discuss in detail about the recent Pamban bridge applications, that is going to be a very interesting case. So my colleague, Mr. Rohit Kumar, will also be joining me to take you through the Pamban bridge story.
Okay.
So with your permission, we start the presentation, sir. I will now share my screen. Okay, so hello everyone, and welcome to you this presentation on bridge bearing choices for railway structures. The flow of this presentation will be like, we will be first understanding what is a bridge bearing, then what is its application. Then we will be discussing in detail what are the different types of bridge bearings available, their advantages and disadvantages concerning railway bridge application. And then we will be going, what is the state of the art in bridge bearings? And thereafter, we will talk about what is the latest innovations and advancements. And at last, we will be discussing about few of the performance aspects that are to be given care and consideration when you are dealing with a bridge bearing. And these aspects are all related either to the design of the product or to the installation or their after installation aspects to ensure that they are properly functioning in the structure. First, to understand what is a bridge bearing, it is always good to start with the basics. So by definition, we can say that it is a mechanical device which is installed in between the substructure and superstructure to control the interaction of these two. That means it has to safely bear and transmit the loads and forces from the superstructure to the substructure, and also at the same time to facilitate for free rotation and movement. Now coming on to bearing types, the different bearing systems which are available for railway bridge applications. Starts with steel bearings that include rocker roller, hinge, and plate bearings. Then we have the elastomeric bearings, disc bearings, pot ptfe bearings, pin fixed and metallic guide bearings, spherical bearings, and the most recent development, the sliding isolation pendulum, which are in short called as SIP bearings. Talking about the conventional bearing systems, these bearings have served the Indian railway structures for a very long time, and they have given a tremendously good service to the structures. But as the name itself suggests, they are made up of steel assemblies altogether, right from the bottom to the top of the bearings. So the advantage of these bearings are they are easy to execute, they are easy to fabricate. The limitations of these bearings is, since it is a complete steel assembly, we have steel to steel component in contact. So when we have too much of movement and rotation taking place, which is a requirement of the modern structures, then you have very high abrasion between two similar property materials. They are rubbing each other and a loss of material and loss of surface is taking place. On the contrary, when there is too less movement or rotation taking place, there is a tendency of steel, if it is kept in an undisturbed condition for long period exposed to environment, then it fuse together. Then after a period of time, the bearing is virtually not rendering any free movement or rotation also. This is one aspect. The other aspect, to understand the limitation of these bearings, we have to go into the degrees of freedom required for any bridge. Generally, a bridge requires from a bearing system or expansion joint system to fulfill certain freedom. And this freedom can be classified into movement possible in three directions: the longitudinal, lateral, and vertical. So this makes 3 degrees of freedom. And the rotation about the three axis. The rotation about the transverse axis is the longitudinal rotation of the bridge, which occurs due to the live load, the sagging of the girder. Then about the x-axis, the transverse rotation, and there is about the vertical axis. Sorry, the vertical axis is the in-plan rotation, and about the transverse axis, the rotation in the bridge transverse direction. So 3 degrees of movement freedom and 3 degrees of rotation freedom makes in total 6 degrees of freedom that can be desired from any bearing system. Now, if you imagine the sketch which is right in front of you, these roller bearings can offer free rotation in the longitudinal direction, but because of a continuous width of roller, it is very easy to understand that these bearings cannot do any rotation in lateral direction. So that limits the degree of freedom in this bearing. Similarly, when we have a fixed rocker bearing, this bearing also cannot offer any movement or any rotation in the transverse direction. So that way, the rocker roller bearings applications are nowadays limited for long span steel bridges, where in addition to longitudinal direction rotation, a lateral direction rotation also is required. The third limitation, or you can say concern, which we have to ensure when we are choosing these bearings for railway applications, is the intensity of force and pressure. Nowadays, since we are going with very long span structures, the spans is going up to 60, 70, or even 150 meters also. The load concentration or the force that comes onto these bearings becomes tremendously high. And because in these cases, there is a curved surface, the roller or rocker has a curved surface, and there is only a very, you can say, a thin line contact for the load transfer, that could also lead to very high crushing strength, and that may not be suitable for the design of the plates or the rollers as such. So all these are the points of caution that we have to pay attention when we consider steel bearings or rocker roller bearings for our bridge applications. Then we come into elastomeric bearings.
So, just a minute. So, just for the sake of clarity, I would like to mention here that in RDSO standard open web girder drawings, up to the span of 91.4 meter, we have provision of roller and rocker bearing made of full metal. Just for the sake of clarity.
Okay, sir.
Please
Okay.
go ahead.
Okay, so the second bearing in our list is the elastomeric bearings. To better understand the construction of this, I would like to take you through a animation that explains the construction of these bearings. I hope the video is coming nice on your screen, sir.
Yes, it's good.
Okay, so a elastomeric bearing is basically a construction of rubber and steel plates together. Uh, It is similar to a sandwich wherein we have two pieces of breads on bottom and top, and in between we have the filling. The same way in case of elastomeric bearing, we have elastomer laminates, rubber laminates, then we have the steel laminates which are sandwiched in between the adjacent rubber layers. So depending on the load requirements and rotation and movement requirements, the thickness or the number of these laminates can be increased, and that way any combination of elastomer and steel laminates is designed. This is a typical fixed elastomeric bearing which is placed in between two steel plates, and this bearing is able to take the vertical load, and it takes the movement and rotation by self deformation. In case the requirement of horizontal force from the bridge structure is exceeding and the inherent capacity of the elastomeric bearing is not adequate enough to safely tolerate that high intensity of force, then the bearing can also be combined with external guides, which then enhance the horizontal force capacity of these bearings. The earlier case was a horizontal force locking in one direction. And this, what you see in front of you, is a typical sketch or example to show the locking of horizontal forces in both the directions. So this way, the entire horizontal force is not getting transferred through the bearing itself, but it is then transferred through this steel locking mechanism, which is provided at the vicinity of the elastomeric bearing. So by now we must have understood that how elastomeric bearing functions. It provides movement and rotation by self deformation, and this then becomes the advantage of this bearing also, since it is no additional component. These bearings are very easy to handle and install. You simply place them in position and transfer the load from the superstructure on them, and they start doing their job. For most of the cases, there is no positive bolts or anchorages also used or required for their locking. They simply stays in position by virtue of friction between rubber and concrete or steel surface. But after we go from a small span to a moderate and from a moderate to high span, this beneficial property of the elastomeric bearing starts becoming its limitation, because these bearing takes movement by self deformation or rotation by self deformation. So the higher is the span, the higher will be the requirement of movement and more will be the deflection, which will over the period of time call for early wear and tear of the rubber. In addition to that, rubber has aging properties. We all know, we all have seen, take example of our tires in our vehicles. And no matter whether we drive the vehicle or we don't drive, after 4 or 5 years, the tire becomes very hard. And we are advised to change the tires. The same is applicable for any rubber product. We find it after a certain point of time, it starts breaking and powder starts coming out of it. So rubber also has that limitation. Over the period of time, it starts showing degradation in its properties. And after a certain period of time, the properties are not good enough to satisfy the behavior which is required. The third limitation which must be kept in mind is the fire resistance. Rubber is not good to fire resistance. If suppose you have a structure which sometimes happens that it catches fire or it comes in the vicinity of very hot atmosphere, then that is also adversely working over the elastomer of the rubber bearings. Then there is another form of bearing. Since this is an informatory session, so I thought I should include this bearing as well. Although there is no mention of this bearings in Indian Railway Code so far, we are working on development of some chapter on disc bearings in Indian Road Congress. But as this point of time, neither the Euro codes nor Indian codes are having any chapter dedicated to this type of bearing. It is quite similar to pod ptfe bearings, but the difference in these bearings and pod ptfe is the disc, what you see here in red color, is also a elastomer disc. But this disc, unlike the elastomeric bearings or pod PTFE, where the disc is mainly made up of neoprene or natural rubber, the disc of these bearings is made up of material called polyetherurethane. And polyetherurethane is a material which has very high shape memory and it is very stiff in nature. Because of this stiffness, the advantage of these bearings is they do not need any confinement for this elastomer disc. We require a confinement of elastomer disc inside the pot because the moment it comes under load, the elastomer starts acting as the fluid. And if we don't confine it inside the disc and don't seal it with a sealing ring, it will ooze out like we see hydraulic oil coming out from our jacks if the sealing system goes wrong. But in this case, it is just simply sitting as a washer in between the two steel components, but it bears the load and it don't deform to the limit that it starts flowing out. And this is the advantage of these bearings also. Again, it results in a simple construction, but this is also the limitation. Limitation in the sense because of very high stiffness of this pad, when the bearing is required to take rotation, and that is very frequent and very high magnitude also in case of railway bridges, the moment you call for a rotation and the higher the magnitude of rotation, more will be the restoring moment or resistance of the disc, and that will adversely affect the performance of the sliding material. We will be understanding this thing more detailed way when we go through a pod bearing animation, but it's just for your understanding. So this limits the rotation capacity of these bearings, and it also results in very high restoring moment, which may cause distress on the sliding material. Coming on to pod PTFE bearings, they are to a great extent, it is not wrong to say that have been most widely used bridge bearing systems in India these days, or for the past 20 years, they have been very widely used. The pod bearing can be perceived, or for the sake of understanding, they can be seen similar to a hydraulic assembly. In a hydraulic assembly, we have a cylinder, and that cylinder is filled with fluid, hydraulic fluid, and then we have a piston. So when the hydraulic fluid is pushed inside the cylinder through a hydraulic power pack, it pushes the piston up and down, and that way a hydraulic assembly moves, let it be a jack or anything. So the concept of a pod PTFE bearing is also more or less similar. Let me also explain you this pod PTFE bearing construction through the animation. The first what you see is the fixed bearing. The bottom component, gray color, is a steel component. It is called pot. Then the black color disc is the elastomer disc, which may be neoprene or natural rubber as per different country specifications. This is the sealing ring, which seals this elastomer in between bottom and top component. This is the external seal or dust seal, which prevent the ingress of dust inside the pot. And this is the top component, which is called piston. So when this assembly is complete, this bearing is able to take vertical load, it is able to offer rotation, and it is able to transfer the horizontal forces in both directions. It does not provide any movement. Now the same assembly is hereby modified, but the top fixed component is now getting different shape, and there is a sliding material on top of it, and we get a third component introduced, which is the top plate, sliding plate. Now, by virtue of this additional component and the sliding interface at the top, this bearing is now able to offer free movement in both directions, in addition to satisfying the vertical load and rotation requirements. Of course, it is not difficult to imagine. This bearing will not be able to take any horizontal force because it is free to move in both directions. And then the third one is a guided bearing. And this guided bearing, because of these guides, is then restricted to move in one direction, but it is free to offer movement in the other direction. Also, the arrangement of guide could be different also. This one is an example of central guided system, which is popular in other countries, but in India, mostly we are following the sideways guide system, where there are two guides projecting from the top plate at the two sides, running parallel to each other.
So for a bridge, these guided bearings are also of two types. One facilitates guiding along the longitudinal axis of the bridge, and one across the longitudinal axis of the bridge. So one is called
That's very correct, sir. It's a good point to mention,
yeah, it's
because in
one is
a bridge
called
structure you have,
one is
sorry,
called longitudinal guided, other is called transverse guided. Yep.
in a bridge you have at least 4 points of supports for one span, and you have to have an arrangement such that the bridge is kept in position and it is having all its movement channelized properly. So one point is fixed, then the bearing sitting adjacent to that fixed bearing is a guided bearing which is free to move in transverse direction. Then the bearing which is sitting in front of the fixed bearing on the other pier is a longitudinal guided bearing which allows the longitudinal movement. And the fourth bearing is a free bearing which allows movement in both longitudinal and transverse direction.
Rathorji,
Now, talking about the,
don't we have any video for disc type bearing?
I don't have a video for disc bearings because it is not being used. We are not doing any disc bearings in India.
Okay.
So I thought just giving information is good enough. I have not compiled any video of it here.
Okay.
Okay. So talking about now the pros and cons of pod bearings. The advantage of pod bearing is whatever the limitations we have discussed so far of the conventional steel bearings or elastomeric bearings does not exist with pod ptfe. It can provide up to 4 degrees of freedom. You remember I talked about the rotation about 3 axis and movement about in 3 direction. So it can satisfy, it makes up to 4 degrees of freedom. And it can be designed with uplifting capability also. Although this is a debatable topic whether it should be done in pod bearing or not, but there is a possibility it can be done that way. Another possibility or advantage of pod ptfe bearings is it is easy to maintain and it is replaceable. Coming on to the limitations or cons, by virtue of the presence of elastomeric component, there is always some compression involved. So the compressibility or spring characteristics of elastomeric bearing, although not that significant, but it still remains in pod ptfe bearings. Another biggest point of concern or caution, which is a regular maintenance issue sometimes, is the effectiveness of the elastomer pad and sealing element. For better illustration and understanding, I have compiled here a photograph of the actual bearings installed under a bridge. And now you could see that this is a very severe rotation condition. We will not go into the details whether this rotation is within the design rotation or it is beyond, but sometimes at site the situation can be like this. Now this picture is to explain you that when we use a pod ptfe bearing, we have to ensure that we are completely avoiding the flow of water or percolation of water to the bearing location. Why? Because the shape or geometry of pod ptfe bearing is such, if suppose the water is dripping from this point and it follows the concrete face path and it then goes up to the bearing location, it will accumulate inside the cylinder. If you can recall the video animation we saw for pod bearing, the cylinder shape is such that everything can accumulate inside it, where the elastomer pad sits. So this standing water in that location will then accelerate the corrosion and it will spoil the face on which the sealing element is doing up and down movement. I will show that in the next animation. And that will seriously compromise with the performance of the bearing and reduces its life. Another important point to note for pod PTFE bearing is, this is mentioned in the code. This is an abstract of IRC 83 part 3. You will also find similar statement in the Euro codes that wherever the rotation requirement is exceeding 0.03 radians, and more importantly, the rotation due to frequent combinations, you can consider it as a live load. And in terms of railway bridges, it is when the rail is coming onto the bridge and by the axle loads, the deck is going or girder is going under a swagging thing. And then the load goes, it comes to its previous condition. So this is a very frequent action of the girder. And what this action is doing, if there is a bearing at the end of the girder, when the girder shakes, the bearing has to do repetitive and frequent rotation. So when the frequent combination rotations is more than 0.005 radians, use of pod bearings is not advisable. Why? Because the pod bearing has, as I told you, internal sealing elements, and there are 3 or 4 most common sealing elements defined in the code. They have a defined life. This life is also given inside the code. Stainless steel sealing, which is highly uncommon, it has a life of 500 meters. Brass sealing has a life of 1000 meter, and POM sealing or PTFE based sealing elements has a life of 2000 meter. This is the sliding capacity of that material before it's worn out. How it affects, we understand through this animation. This is a typical pod PTFE. When the rotation comes, the elastomer gets compressed, and when the elastomer gets compressed, the sealing element, which is sealing the elastomer so that it doesn't ooze out from this clearance, it does a up and down movement. So when this thing happens, due to this continuous rubbing action or filing action of the sealing element, which is a soft material, against this hard steel surface, the sealing element gets worn out and it creates a gap through which the elastomer oozes out. Because elastomer, please remember my statement I gave few slides back, it acts as a fluid under pressure. So the moment there is a gap, a substantial gap, maybe fraction of millimeters created over there, it oozes out. This is what we discuss in theory. On the right side is you see a elastomer pad actually coming out from the pod bearing due to the ineffectiveness of the sealing element. Then these are few more photographs compiled. This shows the corrosion. What standing water can cause inside a pod bearing, which is not to be seen. You cannot judge what is happening inside unless something has failed, because the shape and construction is like that. So these are the components of pod PTFE bearings. After they have failed and we have taken out, we notice that this could be the extent of damage that can happen inside a pod PTFE bearing if you are not giving due care. Second point of concern for pod PTFE bearings is the restoring moment or horizontal load transfer. You all must have seen that pod PTFE bearings are always associated with pin and metallic guide bearings. The pin bearings are used generally or in common with pod PTFE wherever horizontal force is high. Because pod PTFE bearings, when you put them to task against very heavy horizontal force, they have some or the other distress which can be understood through this moment equation which is given inside the code. You have to design a pod PTFE bearing well within the stress levels which you calculate by these moment equations. Why is it so? Because every elastomer has a property called rebound effect or self-restoration. The easiest example is if you have an elastomer, if you have an even rubber band, and I put it in between my fingers, the more I stretch, more I feel the strain on my fingers. But if I just bring it back to its original position, it is not giving any stress to me. So rubber has a tendency, it tries to come to its original position. The more you apply the force, the more will be the strain in the material. So the same thing applies to the elastomer pad of pod PTFE. When the rotation comes and the bearing gets compressed, the elastomer is applying a counter pressure to come to its unstressed condition. In this process, what happens? The sliding material which is there on top to facilitate movement, this material should be getting a more uniform pressure distribution or load distribution, but that load is then concentrated to some portion of this, and there could even be separation at the other end. We see it more clearly in a close view like this. And when this thing happens, this material or this area of the sliding material can get contamination also. Whereas due to the extreme concentration of load on the other end, over the period of time, this material can show destability and it starts flowing out or coming out from its position like this. So these two, what we discussed, one is the issues of the elastomer pad and sealing element. The other is the restoring moment condition. Are the two more common causes of any malfunction or failure that are noticed worldwide in case of pot ptfe bearings. So due to this, there are many specifications worldwide which says that in general for railway bridge applications, it is important for you to understand. The earlier one was the German railway circular, which says pot bearing shall be used with required care and caution, addressing the points of concern. And this is AREMA, which is American Railway Specifications. It says pot type rotational bearings should not be used for support of railroad bridges due to concerns over large cyclic live load deformations and rotations. Which is also, I gave you the IRC code reference, which says the rotation values are limited for pot PTFE bearings. Even there are Indian Railway Circular also, which says for long span structures, pot PTFE bearings can be considered, but there are other bearing systems like spherical which should be preferred for long span structures more than 60 meters and above. So what is a spherical bearing? Let us also understand the spherical bearings, and from here now we start venturing into the modern bearing systems. Up till now we were discussing about the conventional bearing systems. Now in this session we will be discussing the state of the art innovations and developments for railway bridge, which covers the spherical bearings and sliding isolation pendulum bearings as well. We are calling them as bearings for modern structures because we see that the performance requirement for a bridge bearing perspective, especially in case of railway bridges, has changed. It has come a long way from earlier conventional structures which used to be short span, very thick and heavy structures, which were hardly getting any influence from the live load actions. And now the structures that we are seeing these days, you can imagine the very recently we had in the news all over bridges like Chenab Bridge, Anjikhat Bridge or Bogibeel Bridge, which has been recently opened to railway traffic, or some of bridges are getting opened in soon. These bridges has a more pronounced interaction of live load to their dead load, and also the type of construction they are built. Some bridges are cantilever, some bridges could be cable stay also. In future we might see cable stay railway bridges as well. Anjikhat is a live example. So that way these bridges are more dynamic, and therefore from a bearing perspective, if you see, the requirement of rotations and movement is more pronounced. It is heavy or higher in terms of frequency, magnitude and velocity. So you definitely need to have a bearing system which can complement this frequent dynamic requirement of the structure. And we see spherical bearings as the most viable choice for such applications. Why? We understand through this video. In case of a spherical bearing, we have the concave and convex component interface for the rotation purpose, and there is a lining of low friction material in between. The thermal movement or translation is similar as we see in case of pot PTFE due to this flat sliding surface. But as we have shown previously in case of pot PTFE, there is a disc of elastomer and it compressed to offer the rotation. In case of spherical, the rotation is taken care of by curved surface sliding. So here we have a bottom concave shape component and a matching convex, and these two slides relatively to offer the rotation. You see now in the video animation, when the rotation comes, This sphere slides over the bottom, and that way the rotation is taken care of. Let us now understand the three basic configurations of a spherical bearing. This is a fixed spherical bearing. We have a bottom component which has this concave shape machined inside it. Then there is lining of this low friction material. It could be ptfe or any other improved sliding material. Then we have the matching convex component, which is also made up of steel. But there are two, three different options specified in the code for this component to be. Either it could be a fine-grained fine-grained rolled steel, which has a chrome plating at its sliding interface, or this can be made up of stainless steel with a polished surface, or there is also a third option. It can be made with a special grade aluminum alloy, which has a very good sliding properties against the PTFE or sliding material. Then on top of this middle component, which is called callot, we have a flat sliding material, and then we have the top component, which locks against the bottom component directly, so that all the forces is directly transferred from superstructure to this component and from this component to the bottom component. And this way, this bearing takes the transfer of the forces from top to bottom directly, and therefore it helps in stability of this bearing by a great extent. So this bearing takes the rotation like this. It takes the vertical load and resists horizontal force in both directions. Next is a free bearing. Similar to pot, here also the shape of this component is different. And sorry, the shape of top component is different, and it is flat plate to offer free sliding in both directions. So this top component becoming a flat uh, rectangular plate, and this way it facilitates free movement in both direction.
So this is
And the
basically
bearing is
free
able to
bearing.
take rotation and transfer of vertical load.
So basically, it is free bearing.
It's a free bearing. And the third one in the basic configuration category is the guided, which you can see because of these guides introduced. It cannot move in the lateral direction. It transfers force in that. And in addition, it satisfies all the other performance parameters like vertical load, rotation, free movement in one direction. Now here I would like to take you back to the first video of the animation of this video. This is a fixed spherical bearing, which is a three-component bearing. If you turn the pages of IRC 83 Part 4, which is the spherical bearing code, there you get to see two configurations of fixed bearing. The first configuration of a fixed bearing is having two components, which has only the bottom component, and this component itself is having a lux, which is used to fix it with superstructure. So an obvious question may be coming to your mind that what is the difference in between two component fixed and three component fixed? You imagine if we have a bearing like this. Imagine this is my top component, because I'm using this mouse because it has a certain curvature at the bottom. And this is my bottom component. If I fix the bottom component with my pedestal and this top component is fixed with superstructure, and if I just try to show you from the top, now this is the plan you're seeing from the top. When this component does the rotation, it has a shift in plan also. The bottom component is fixed on pedestal, but this top component is shifting in plan also as it does the rotation. And this shift in plan may not be possible or may not be advisable when you have a bridge which has a fixed position and it is doing a sagging movement, but you cannot allow that bridge to move from its position, right? So therefore, the two component geometry of fixed bearing is generally not advisable. Some manufacturer does it, but they have to be very careful in checking whether that shift in plan from the top component, is it within the capacity or within the purview of the superstructure, or it is going to adversely interact with the structure. In this three component design, which most of the manufacturers in India is following by and large, the top component is locked with bottom and the rotation is done by this middle component. But the top component is then not dislocating from its position. So that is the benefit or the advantage of having a three component design, that when the bearing rotates, the middle component dislocates, but it is dislocating within the top component, and the top component is then holding its position with respect to the footprint of the bearing. So that I wanted to explain by taking extra time on this video.
Very good point. So, as a procuring entity, if any deputy chief engineer or chief engineer in the field are placing orders for these bearings, they should specifically look for these points. Although, as mentioned, most of the manufacturers are following this, but still to have this knowledge and to put it in writing is a very good, I mean, option, so that our bearing quality is not compromised in any way. Thank you for making this point.
Thank you, sir. So that was, I think, we have tried to give you an understanding that how spherical bearings are called as improved or better than pot ptfe bearings, because they eliminate the elastomer pad and sealing element. So there is no concern of the sealing element doing up and down movement with the hard surface and getting worn out and the elastomer oozing out. Also, there is no elastomer pad. So when you have high rotation also, there is no heavy restoring moment getting developed. So spherical bearings in that sense are able to take very high rotation. They are able to withstand very high combination of horizontal loads and forces. In most of the cases, we generally don't find a requirement of placing a pin bearing adjacent to a spherical bearing, because since the horizontal force is getting transferred from the top component to bottom component, the bearings are able to resist any combination of horizontal force to vertical load within them itself, and there is no need to go for additional pin bearings when you go with spherical. Now we move on to the sliding material. Sliding material we will be discussing in short. We just want to give you an understanding that what are the new advancements in sliding material also. The best known or the most commonly known sliding materials being used in bridge bearings is ptfe. PTFE stands for polytetrafluoroethylene. Another common name of this is Teflon also. And this material is used because it has the lowest value of friction when checked against a polished sheet of stainless steel. So the bridge bearings are also heavy, need to have a desirable feature that when they move, they should offer minimum resistance to the structure while causing the movement, so that the structure doesn't get overstressed. And this friction value should not be more than 3% to 5%. It is defined in the code. So when this PTFE, it has dimples. These dimples are filled with grease. So this lubricated sliding interface of PTFE and stainless steel, it offers very low friction value. Now, through this case study, we need to understand the limitations of PTFE. What are the limitations of PTFE? This is again a rail bridge. It's a rail cum road bridge. And this bridge is so dynamic in nature that when the train is moving through this bridge, the parameters of performance recorded at the bearing location were quite alarming or quite interesting. You could see the amplitude of movement at the bearing location was up to 150 millimeter. And this movement, when added or multiplied by the number of trains moving in a day and number of trains or number of days in a year, it was accumulated to a movement value in excess of 10,000 meters in a year. Now, on a lighter note, we all understand or we all imagine bearing as a stationary devices. They are just dead devices sitting in their place. But how many of us had imagined before this that the total sliding that is taking place in these bearings could be more than 10 kilometers in a year? So that is something we all have to understand the seriousness and gravity of this subject. And the velocity at which this movement takes place, sometimes it could be very fast, because when a train with very high velocity enters onto a bridge or it leaves a bridge, it creates a lot of dragging and pushing force, and this bridge could have all of a sudden, from a very you can say stationary position, it can have a sudden movement as well. And we observed the PTFE in many bridge bearings giving up quite prematurely. These are the photographs of, again, real bearings taken out from bridges. We don't name the bridge because it is not relevant to the topic, also not correct, but these are the actual bridge bearing photographs. And the reason behind this lies within this test. This is the outcome of a long-term slide test, wherein you could see that after 10 kilometer of sliding, the entire PTFE has crystallized. I mean, it is a thermoplastic material, so it has this tendency, it loses its stability when you have the temperature rise, or when you have sudden movement, or you have a lot of movement taking place, and it has settled in paste or powder form on the melting surface. And this happened when the stress concentration was 30 MPa and the velocity at which this test was performed is 2 millimeter per second. And if you refer to the EN standards, EN 1337 part 2, which is for sliding material, you will find there mentioned that the total sliding path of PTFE is 10,242 meters only. That is coincident with this value. In addition to that, there are temperature concerns. Why it is important for railway bridge? I included it here in this presentation. My colleague and myself thought it is very important because any thermoplastic material will have a temperature sensitivity. A thermoplastic, in general terms, if I have to explain you, it is neither as soft as rubber nor as sturdy and hard as steel. It is somewhere in between. So when the temperature rises, the material loses its stability. And this high temperature is a common thing which we notice in our country, in India, right from north to south. Even if we talk about a bridge which is in Delhi region or in Bihar, there in peak summers, the open air temperature could go up to 48, 50 degrees even. And especially talking about railway bridges, how they differ, how this thing is become more important in railway bridges for two reasons. In case of highway bridges, it is mostly concrete and it is a closed structure. The bearing hardly receives sunlight directly on it. In case of railway bridges, it is an open skeleton and there are parts of the bearings which can directly come under sunlight and that raises the temperature level like anything. You all have experienced this thing in your life. Different component have different temperature gradient. Concrete, wood, and steel, if you keep three metals or three materials in summer open direct to sunlight, wood won't feel hot. Concrete will feel little hot, but you cannot touch steel. It will become red hot. The same applies on colder weather. In extreme cold, low temperatures, if you by any accidentally you touch a steel surface, you feel a lot of cold because the temperature gradient of material moves differently as compared to air temperature or environment temperature. So when you have steel bearings, in case of railway bridges, directly exposed to very hot temperature, the temperature increase in the sliding material, which is directly in contact with the steel plate only, can go very high. And it is a clear caution mentioned in the code that PTFE cannot be used for any temperature exposure more than 48 degrees centigrade. This is a very important point to understand. So we have to check this condition. One thing. The second thing, all codes, whether it is Eurocode or it is IRC 83, it says that beyond an increase in temperature from 30 degrees centigrade, you have to apply a 2% reduction in the permissible pressure on this material. Like here we have compiled a calculation. If suppose we are designing a bearing for some part of the India, where according to the temperature isoplate temperature graph, the maximum temperature exposure is 47, which is 17 degrees above the threshold value for ptfe 30 degrees. That means we have to apply 17 times 2, 34% reduction in its strength, maximum permissible strength given in the code for design. So this is the important check which you as a client must ensure that the bearing manufacturer has applied in his code and he is giving you a right size bearing for your kind of temperature exposure or your bridge structure. Okay, so that was limitations. Now there are some new and innovative sliding materials also developed, and these materials were, again, the history is very interesting. There was once upon a time in Germany, maglev trains were planned. Maglevs are magnetic levitation trains. And when the parameters were laid down for these train bridges, they say that with the passage of every train, the amplitude of movement was 7 millimeter defined. And this will accumulate to a total accumulated movement per year of 625 meters. That is 0.6 kilometer in 1 year. And they demanded a lifespan of 80 years from the bearing. Now, if we go a few slides back, when PTFE can deliver in totality 10 kilometers, and you require more than half a kilometer in 1 year, now PTFE can last at max 17 years or 18 years for this particular application, but they required a bearing system of 80 years. So Maurer took the task of developing a new innovative sliding material, and they did research for 4 to 5 years, and they developed a material which they named as MSM. MSM is their brand name, but the generic material is UHMWPE, ultra high molecular weight polyethylene. Now, this is the generic name, but in short, many specifications have now adopted this material. Like Australian code has included this material in the code itself. They have named it ASM. ASM stands for approved sliding material. So from now on, we will be talking it as a ASM, because approved sliding material need not be only PTFE or UHMWP. It could be any innovative sliding material which has been developed, tested, and qualified for those performance parameters. So the advantage of this approved sliding material is that it offers a substantially high improvement in the total slide path. In case of PTFE 10 kilometers, it can go up to 50 kilometers. In case of PTFE sliding moment velocity 2 millimeter, it can support up to 15 millimeter. And the stress level, load carrying capacity is also here double than PTFE. So if we have a side-by-side comparison, we can say that whatever were the limitations of using PTFE in bridge bearings, this has been not only overcome but surpassed by a great margin with these approved sliding materials or innovative sliding materials. And the new bearings, whether it is spherical bearing or pod PTFE, those are equipped with this approved sliding materials, can now sustain very fast movements. They can accommodate high loads and stresses, offer low value of friction, and thus they result in highest lifetime. This is a temperature graph. I have the values here compared between PTFE and UHMWP. The original or initial strength of both the material is different. UHMWP has double strength, but it is also thermoplastic material. So it is important for you to understand that it also has sensitivity to temperature. And when the temperature exceeds beyond 35, which is the threshold value for UHMWP, 30 is the value for PTFE, there is again a reduction in the pressure applied for this material also. But you can see around 50 degrees centigrade, even the residual strength of these innovative approved sliding materials is much higher than the original strength of PTFE. So they are advantageous in any environment and any temperature application. What all I have just said, to give it a summary, I have this video animation. When the temperature rises, you could see the PTFE starts melting first or start destabilizing first. And when something destabilizes, it becomes sticky. And when it becomes sticky, it further increases the friction. And when the friction further increases, it starts increasing heat. In cold weathers, when we feel cold, what we do? We apply force and we rub our hand. So by virtue of friction, heat is generated, we feel warmer. So the same thing is there. So it triggers a cyclic action. Whereas in case of UHMWP, approved UHMWP, it is able to tolerate a temperature exposure up to 110 degrees centigrade also. This is mentioned in the approval documents that if the material is of proper grade, proper construction, the compound is correct, it can go up to a temperature exposure of 110 degrees also. Coming on to the design part, the advantages that we get by using these innovative sliding material is a compact bearing shape and form. For a given load, when we design with all the stress reduction for high temperature, for 20,000 kilonewton, if we require a disc of 700 millimeter for ptfe, a size of 470 millimeter can be doable with a innovative sliding material. So how this helps? I quote you an example of bogie wheel bridge. Bogie wheel bridge has bearings of very high load capacity, almost about 2,700 kilonewton or 2,900 kilonewton. I don't exactly remember the figure now, but they are able to get accommodated within a very small pedestal size of 1.5 meter, I think. So that's the advantage of these innovative sliding materials, and the spherical bearings when equipped with this material. Their footprint is about 70% that of a conventional bearing. And in turn, you can have saving in terms of pedestal and pier cap concrete and steel, which is also a national saving. And this is besides the saving that you get in the material of bearing itself.
But there occurs another problem if we reduce the pot size to beyond a limit. Basically, when the spans are very long, so what happens? The section of bottom cord becomes very wide. And when we
Mm-hmm.
provide a small pot below this, so the section
Mm-hmm.
has a tendency to, bend like this. And this results
Yeah.
into the bending of bottom lateral bracing gusset plate also. And there is a clear
Yeah.
gap visible between the top plate of the bearing and the bottom lateral and the bottom flanges of the this thing, bottom cord. So this is a
Yes.
major problem there. So designers somehow they satisfy this when they design the bearing. They structurally the bearing is okay, but the thing is, what happens over a time? The top plate starts bending, and sometimes cracks are also developed over the time. So I think there should be some criteria for having a minimum, diameter of this pot so that
Yeah.
the overhang of the cantilever portion is not much.
You are very correct, sir. This point must be given somewhere adequate attention. And this reminds me of another concern, the open web girders, the application of bearings under open web girders. I think in our quality section, which Mr. Rohit is going to take up in maybe 10 minutes from now, we need to emphasize on this point more over there. Okay. So when we talk about the performance lifespan or serviceability of the bearings, uh, the lifespan is decided or governed by the life of the weakest element inside the assembly. Once it fails, the bearing renders non-functional. And when we have these improved sliding materials better than PTFE on the pressure, friction, displacement, and velocity, almost all parameters, they are 2 to 7 times improved. So that results in a bearing system which offers the highest service life. So the spherical bearings with modified UHMWP are the bearing systems available which are assured in the approval document as having a service life of minimum 50 years. Now, here in this one slide, I would like to emphasize on the importance of the qualification and performance suitability, because uh, there could be UHMWP available in the industry, which is being used since decades for many industrial applications. But it is not that the same UHMWP can be molded in a disc form and straight away applied into a bearing and it delivers the same performance. This basic UHMWP has been adopted. It has been further compounded and blended with different additives and fillers inside it to enhance its performance, which are required for bridge bearing application. And they can never be ascertained just by doing mere chemical composition or physical property test. there are a series of qualification and prototype research tests done on this material after it has been developed and compounded to ensure that yes, now this final compound is of the right property which can be used in a bridge bearing application. If we go into details of these international codes, Euro codes for that matter, technical approvals like ETAs, our IRC code, it specifies how the qualification of this material is to be judged. And we, you as a client, request you to always ensure that if you are going with any approved sliding material other than PTFE, because PTFE is a virgin PTFE, it is to be used in its purest form. There it is easy to verify by physical properties. But for these approved sliding materials, unless the proper qualification is not there, you just don't use it on the face value or on the word assurance and commitments of the manufacturer itself. You always must cross check the qualification of that material. These are all the tests and the parameters that are specified in the code. I am not going inside it, but they are always required to be done for maintaining the quality of that material and ensuring that it is of the right compound. This is long-term sliding test, which is 50-kilometer slide test on the approved sliding material done for its qualification. And in this 50 kilometer of sliding, three parameters are continuously changing. One is the pressure. The pressure is changing from 5 MPa to full 180 MPa. The other one is the speed of sliding. The speed of sliding is changing from 2 millimeter per second to 15 millimeter per second. And again coming back to 2, then again changing. And the third is the temperature. The temperature of this test specimen is being changed from minus 50 degrees centigrade to plus 70, then coming back to minus 50, then going to plus 70. So all these three parameters are changing in a cyclic or sinusoidal way, and the specimen is tested for 50,000 meters sliding. And then it should not result in a loss of the material thickness by more than a certain millimeter. So that is one, not the entire, but one of the several tests that are to be done to make this material qualified. Now, talking about the acceptance or the use of these bearings, in India, we also had in past the RDSO draft code for spherical bearings. IRC 83 Part 4 has been published in the year 2014. We have various amendments also in IRC. Here, it is important to show that the latest amendment of IRC 83 has removed the name of the sliding material UHMWP from there inside. Earlier in the code, it was mentioned by the name low friction sliding material PTFE or UHMWP. Now it says low friction sliding material, that's all. It says there could be either PTFE used in the bearing as a sliding material, or it could be any other innovative sliding material which fulfills the qualification criteria. Here also, they have mentioned earlier the approval document name ETA or FHW or similar. Now they have removed the names of the qualification document, but the requirement of the qualification is kept exactly similar. The material has to go through the complete qualification. It should have a valid technical approval, and that technical approval should not be just the material test certificate. It should be a compiled document which covers all aspects related to its design, material, manufacturing, tolerances, and installation even also is covered inside. It clearly mentions isolated approvals or qualification of individual component of the bearing cannot be considered as the approval document. One thing to note as important here for you as clients, that earlier the IRC code was mentioning some values of this UHMWP sliding material, and manufacturers were simply using any UHMWP and taking these values there and then designing, not really paying care to what will happen in the structure after 5-10 years. That material will not be able to perform with these stress parameters because it is a generic UHMWP, not the developed one, not the approved one. So in the amendment, IRC has removed those properties of UHMWP from the table, and it has clearly mentioned that you use any approved sliding material, not necessarily UHMWP only, but there has to be a technical approval available for it, and all the performance parameters, including the design values, its tolerances, its process of fixing, everything should be well mentioned and covered inside its approval document. So these things are important points for you as a client to make note when you are accepting any supplier submission and checking their bearing system.
So
There are see
just to summarize, at present in IRC 83 Part 4, as far as sliding material is concerned, there are two options available. Number one is ptfe, and number two, the earlier UHMWP word has been removed, and instead any sliding material which has got acceptance from approval agencies as per the provisions mentioned in the IRC code can be used. So this is basically
yes,
the current situation is.
exactly, sir, exactly. And now this technical approval, what should be the shape and form of that approval is also defined in the IRC code. Some manufacturers claim that they have produced some bearings and they have got those bearings load tested, final acceptance testing of those bearings by independent agencies like RITES or CIL, so that becomes their approval. No, that is just those agencies, they came and they witnessed the load testing. They have not done any qualification of the material. It is not a technical approval of that material. So please be refrain from such arguments and always check against the right way specified in the code. Now, I will take you through few case studies at last of my portion of presentation. Then Mr. Rohit will take over. This is the case study of rail cum road bridge in Hong Kong. And this is
We have 4 minutes left. Okay.
okay. So I will try to cover up in this 4 minutes. Then we will have another session. These there also the bearings were there, but because of some design issues, the bearings were not able to perform and deliver. So they changed the bearing systems. We will be talking about what are these concerns, maybe in some other part. And it is important to therefore maintain and regularly inspect the bearing systems. Another good example of these modern bearing applications is Signature Bridge Delhi, which has world's largest bearings installed therein. They are 17,000 ton service and 23,000 tons ultimate load capacity. And each bearing weighs around 22 tons. Then comes our rail cum road bridge bogie beam. This is also equipped with UHMWP spherical bearings. Earlier, there was a complicated arrangement of pot bearing with some seismic restrainers suggested, but then later on, during the stage of execution of the bridge, they changed it to spherical. Most recent example is our high-speed rail, regional rail connectivity in Delhi to Ghaziabad, National Capital Region Transport Corporation, NCRTC, what we call. And they have used in their entire stretch spherical bearings. We have supplied there, I guess, more than 7,000 numbers of MSM spherical bearings, UHMWP spherical bearings in this bridge. We are also supplying elastomeric bearings to high-speed rail. And that was just to give you a brief about some major and prestigious railway bridges in India where these bearing systems have been used. Now, in the next session, my colleague, Mr. Rohit Kumar, will take over and he will take you through the ship bearings, its application in one of the most fascinating structure in India, Pamban Bridge. He will explain you about that bridge since he is handling that project by himself.
So just starting with in continuation with the existing presentation, what Mr. Rathore has been explained to you about the bridge bearings. And it is also a part of this same system, what Mr. Rathore has already explained. Like what he has explained is the spherical bearings. So these bearings are bearings which are used in the structures like highway bridges and railway bridges. But sometimes there is a requirement comes that you have a requirement of seismic areas where the seismic force are quite effective, just like our Bhuj area, Gujarat, and in Assam region or in our north region, we can say Uttarakhand. These regions are having impact of the seismic events. So for that, there is a modification done, which we have done, and developed this spherical bearing in a new innovative form, which we called as sliding isolation pendulum bearings. So why we are saying as isolation pendulum bearing is, since it is working based on the principle of pendulum, I'm just representing you one demonstration of this bearing so that you will be getting a clear idea about it. So as I said, the principle behind these bearings are pendulum. So you can see this is a pendulum. How it works is, when you free it in a environment, it will start oscillating, and this oscillation will continue till it will be moving under the conditions of the structure, and then after it will be settled to its original position. So this is the basic concept of isolation pendulum bearing. In case of normal bearings, what we called as spherical bearings or pot ptfe bearing, there are, you have seen, three major types, like the fixed, free, and guided. But in case of isolation pendulum bearing, the concept is totally different. The structure is start oscillating with respect to the force and come to its original position under this condition. So this is a new structure that we call this new permanent bridge. So requirement you can see here is, there is a movement of ships in the sea, and in addition to that, there is a requirement of movement of trains. So you can see the train has also need to be passed. Come on to the bearing part. So you can see this is a new permanent bridge. I hope my cursor is visible to you. This entire structure is settled over the bearings. 4 special arranged bearing was used in this structure. The reason for showing the animation is because there is a special requirement of lifting up arrangement. This bridge structure is not to be settled at one position only. What is happening is, whenever there is a requirement of movement of ship, this structure has to lift up. And then after that, when the ships has been moved, there is a requirement of train which also need to pass over this structure. So at that time, you have to again relocate this structure to its original position.
Yes.
For this requirement, the normal bearings, what we have used conventionally in our structures, will not perform. So for that reason, there is a special bearings which we have used and called as isolation pendulum bearing.
So
The bearings you have seen on,
what problem is anticipated if we use normal spherical bearings, for example?
it will not be recentered with its general condition. Like I am showing you in one animation, I think Mr. Rathore has already shown you. I am just coming on to this animation once again. Here you can see, in this is the basic difference in a spherical bearing and isolation pendulum bearing. So you can see here, this is your normal spherical bearing. How it perform is, it will take a rotation and movement like this. This is the movement part. And then for the rotation part. But now with the modification inside these bearings, we can develop it and giving an extra curvature to its top components and the middle component. So now you can see a comparison between the normal spherical bearing at the bottom and the isolation pendulum bearing at the top. How it performing it? When the movements come, the isolation pendulum bearing will come on its original position without any external movement over the structure. So that is the basic requirements in permanent bridge also, that whenever the structure goes down and settled to on its position, it is a requirement that it will be settled to in its original position without any kind of dislocation. So for that purpose, isolation pendulum bearings are used. I am coming over the slide of the bearing, what we have been used. So these are the bearings. If you can see, these bearings are not similar to the normal bearings. There is having a spatial arrangement Over, you can see some kind of a spring arrangements are also there, and having a special alloy material is also used in these bearing. These images are the actual images of the bearing which is installed at the location, at the site location. Now here you can see, this is the bearing which has been installed, and this is the image which give you an indication that what is actually happen when the structure is lifting up. So this is the top structure and it is start lifting up, and along with this structure, the one part of bearing will be lifting with the structure upside, and the other components are having on its original position of this structure. Now, when this purpose of this lifting has been completed and ships or any other thing has been passed from the structure at the bottom of the structure, then structure will comes down, and this spatial arrangement and this spatial bearings will be helping the structure to comes on its original position without affecting any dislocation in the entire structure. Now you can also imagine these things in case of spherical bearing or in case of pod bearing, there is no possibility of opening and closing. These special bearings are designed that can even open and close with its components and again comes to its original position under the working condition of this structure. So this is the major and the special requirement of this structure which we have been fulfilled by using these special bearings.
Yeah, here. So here, I mean, all the 4 bearings are identical.
All 4 bearings are identical. Only difference is the movement capacity. At one end, there is a movement requirement of approximately 100 mm plus minus 100 mm. And at the other end, which we consider as a fixed, or you can say a structure where having a movement of only plus minus 25 mm. Other than that, all bearings are identical.
So that means that the base of our spherical bearing, where the arrangement for rotational movement is there, so that is the base in all these 4 bearings.
Yes.
Here also.
Correct.
And apart from that, on one end we have 2 bearings. So there would be no longitudinal or lateral movement arrangement.
They have longitudinal and lateral movement arrangement, but limited to 25 mm.
25
mm.
25 mm.
25 mm.
And on the other end,
it is 100 mm.
100 mm, comparatively higher.
Yes.
Okay.
Yes.
And apart from that, on the top of it, we have a centering arrangement, basically.
Exactly.
So
this is the special requirement of the structure, and that can only be achieved by using this kind of special bearing.
Okay. And what this in the girder portion, we have joined this element, this one, huh?
Yes. So this you can see, sir, this is a top plate and this is a middle component, what you have seen in your spherical bearing, which normally we call it piston or a calotte. So this calotte is completely connected with the top component of the bearing, which is normally top plate. And the bottom component is stable on its original position. It is also having a curvature at the bottom, and this will be staying at its original position.
So this particular portion which is attached with the girder, can we go to the breakup of our spherical bearing? What is it?
Yes, sir. I can show you. Show you in case of spherical bearing, what is exactly there is. So in that case, sir, like in a spherical bearing, you can see these 3 components are, in case of spherical bearings, bottom is connected with the bottom structure, top is connected with the top structure, and middle is just placing over the bottom component. But in case of Pumban bridge and isolation pendulum bearing, this middle component is connected with the top component of the bearing, so that it will be lifted up along with the structure, and when it comes down, it will comes and settle over the remaining component.
So this concave portion remains below, and apart from this, all other components are attached to the bottom.
I can show you, sir. You can very easily able to see this thing also in the image. if you can see here, this is a concave surface.
So,
This
but
is a concave surface.
this is devoid of any, I mean, sliding material. There is no sliding
Exactly,
material.
because yes, it is without any kind of sliding material. The reason is at that particular portion, if there is some kind of sliding component or material was there, this bearing is having a requirement of opening and closing. And during this process, if something comes in between these two components, and after that, when it start working, what is happening is this thermoplastic material will be damaged. So what we have considered during the designing of this bearing is we have using a special alloy at the top and the bottom also. And now this alloy has been connected with each other and then start working during the condition is requirement of the structure.
So basically, this is a metal to metal contact.
It is a metal to metal contact, but it is a special alloy metal.
Okay.
Once it has been settled down, you can see, sir, like this, when it is settled down, it will comes in its single component. What is happening is this component, what we have seen here, is start oscillating at the bottom of its component. I can show you, I suppose, in one of the image. This is also visible. You can see this bottom plate is having a curvature, again a curvature at the bottom. So this, once it will be settling down with the middle component, then after it will becomes a one component, and this single component will start rotating at the bottom of the component, the bottom plate of the bearing. This is the bottom plate. This is the top, middle having a two component. One is going with the structure. A bottom is connected with the bottom component, and the bottom component again having a sliding arrangement at the bottom surface, which is below this plate, below this SS plate.
So it appears from the image that some springs have been given. So why we are
Yes.
allowing this to move actually? Because if this is the base, it could have been designed as a fixed part also.
No, sir. The purpose of these springs are to achieve 100% recentering capacity of the bearing. Like you, I already explained you that at one end there is a movement of only plus minus and 25 mm. At that end there is no spring arrangement was there. It will be automatically settled to its original position.
Acha.
But at the end where the movement is more 100 mm, which is around approximately 4 times than the existing the other location of the bearing, then it required an additional arrangement to get a full centering capacity of this component. That is why this springs arrangement was there.
So basically upper part will move by say 75 mm, suppose it moves.
Yes.
When it comes down, it needs a matching phase.
Yes.
So
Yes.
unless the base is allowed to move a little bit in proportion to what movement is there in the upper part, we cannot do its centering basically.
Exactly.
Okay.
And in normal bearings, sir, if we can say in normal isolation bearings, this kind of arrangement was not there. They are again having a three component arrangement similar to spherical bearings, but only difference is there is an additional curvature at the top and the middle component. But this is a special bearings which is having a requirement of lifting up and down. That is why it is having a separate kind of component arrangement, which is one is lifting with this structure and one is settled with the bottom component.
And where is that the top plate was concave convex surfaces were meeting in this photo? Where is that?
So this is a concave surface. You can see here this is a concave surface, and at the top there is this is a convex surface.
No, in the animation we saw that on the top plate we had this arrangement of.
Okay. So at that point, sir, in this case also above this component there is a curvature.
Acha.
Above this component there is a curvature which is allowing which fulfill the requirement of the structure.
Okay.
So this is all about this special bearings which is used in Pamban bridge.
Okay. So we can move ahead with the.
Okay. So other than that, sir, structures having a requirement of uplift forces, which is because of change in temperature. And at that time, if there is no proper arrangement or no proper anti-uplift arrangement bearings was used, there is a major damage comes in the structure. You can see here, there is a dislocation of span from its original position. I am just showing you one animation so that you will be getting an exact idea what exactly happened to the bearing under the uplift force applicable over it. This is the bearing, sir. And whenever the uplift force comes, you can see the guiding arrangement is start moving. So this will create a situation like you can say a situation of fatigue or creep, because every time when this requirement comes to the structure, the guides or the gussets will start connecting with the supporting members. And if it is not properly strengthened, or you can say after time interval, there is a chances of creating cracks in the component that will damage the guides of the bearing, and at that time this kind of situation will be happen to the structure.
I
So
was
for that
looking at,
situation,
yeah, I was looking at one of the bearing designs and drawings of NF Railway. So there
yes,
they are using this kind of arrangement, that this kind
uplift
of
arrangement.
anti-upliftment arrangement.
So there is two major things, sir. The thing is like if it is a service condition uplift, then you have a requirement of your requirement is more severe comparison to the uplift which is coming in ultimate cases, because ultimate case comes once in a while or maybe not in the structure in the entire lifespan of the structure. But if it is coming in a day-to-day basis or the service condition of the structure, then it will be more severe. If it is a condition, then you are facing an uplift of your structure in day-to-day basis, then you have to design
No,
a bearing
not day-to-day
accordingly.
basis, not day-to-day basis. They were using it from seismic upliftment point of view.
Seismic uplift only. So that is why this gazette was there, because that can works only when it's a seismic case was there. But if it is comes in day-to-day basis or in regular basis, then there is a special kind of bearings available in India which has to be used for this particular purpose. Yes. So this is a advanced form, you can say, advanced form of spherical bearing, which can work for in case of uplift forces, even in case of service condition. So this is a special design, and having a special arrangement can work without any kind of separation or any kind of open loop. This bearing will perfectly work with this structure. So this additionally, there is a transport bracket always you will be finding at the time of bearing. Whenever you have receiving a bearing, this has to be removed after perfect installation of the bearing. So the point here is to find out the correct bearing at the correct position, because it is also a very important point during the installation of bearing. At the top, normally what person has been seeing is, if it is a circular kind of arrangement, it is a fixed bearing. If it is having a rectangular component, then it will come in a guided or a free bearing. But the important thing is to identify the correct bearing. In every manufacturer, in case of every manufacturer, they are using a identification mark over the bearing. In our case, this circle will indicate a fixed kind of bearing. If there is an arrow mentioned in all four directions, that will indicates you a free kind of bearing. And the bearing having a unidirectional, having a directional movement. So that is also mentioned over the bearing, whether it is a longitudinal type or it is a guided type. After this identification, it is also need to check the correct
So,
orientation of the
any
bearing.
demarcation for longitudinal guided and transverse guided separately?
Normally, in case of longitudinal guided, you will be finding out the name with longitudinal guided. Here you can see KGEQ, that is representing for the transverse guided bearing. If it is a longitudinal, then you will find it KGE, and the direction of movement is always there for understanding the direction of movement of the bearing.
Okay.
In addition to that, it is also very important to check if there is any kind of preset movement or rotation is required in this structure, because
If it is wrongly placed at the location, then your bearing will not be perfectly working, because your requirement of preset, maybe you can suppose in other direction and you have placed a bearing in wrong direction, then the total capacity of the bearing has been deteriorated. In every manufacturer drawings, you will be getting a very clear idea about the presetting applicability or the requirement if they have considered during the designing of the bearing. In our case, this kind of arrangement you will be finding out, which we have been indicating that how much presetting we have been followed in a case of our bearings. Then after, there is an important part that the dowels or the distribution plate shall be properly grout with the adequate compact of bedding mortar grout material in the loaded area, because if there is some kind of honeycombing or non-proper grout has been used, then there is a possibility that you will be finding gaps, and these gaps will create, under loading condition, will create a damage of bearing component, and it will further damage the structure other parts also. So these all are the process which is used during the installation of the bearing, like plastic tube insertion deep underneath the bearing shall be used, or a small chain for towing back and forth for proper grouting flow, and air release shall be used. Now with this all, you have getting a general conclusion that we have advanced bearings available in the market which can fulfill almost all the requirement of the structure, and bearings which are capable of taking higher stresses and loaded with higher rotations and movement requirements, and also capable for taking higher velocity displacements. It can giving you a lower frictional coefficient, much more wear resistance, and stability at higher temperature also. These bearings are giving you a highest lifetime in the entire structure life. Other than that, sir, modern specification, as you seen, that there is a requirement comes for the, or you can say it's a demand of the structure that bearing has to survive for last 100 years. So it will all depends on the process what we have been using, or we can say what kind of product we are using. Like expansion joints and bearings are cost not more than 0.5 to 1.5% of the total cost of structure. This small higher initial investment cost save up to 70% of long-term maintenance cost. And maintenance cost otherwise for initial low-tech copy systems could go up to 6% of the bridge cost. And it is very easy to understand that replacement cost could reach us up to 10%. So authority has to decide when to spend the money at the beginning, smaller or huge cost in time. This is all from our side, sir. If you have any question related to our presentation or you want to contact us, please use our contact details.
Sure. Thank you, Rohit, and thank you, Rathorji, for this wonderful session. It was really, really enlightening. And I hope it is received well in the Bridge fraternity. And they will learn a lot with the help of this wonderful, wonderful session. And I mean, you have prepared beyond my expectations, because I was able to see very nice animations, and one can definitely imagine and conceptualize what are the various components, how are they arranged. It will definitely help a lot to the bridge fraternity, to the bridge professionals who are trying to learn about the bridge bearings. Thank you very much once again for this wonderful session. Thank you. Thank you very much.
Thank you, sir. Thank you for sharing a bit, for allowing us to become a part of your this initiative, and giving back to the fraternity, giving back to the industry is always something which we like to do. So we are always available, whatever way we can support your cause, sir. Thank you very much. Thanks a lot.
Thank you. Thank you.
Thank you, sir. Thank
Okay.
you.
Thank you very much.